Vectors are fundamental tools in data science, representing data and enabling powerful mathematical operations. They are used to represent features, data points, or measurements in multidimensional spaces. In this lesson, we'll explore what vectors are, how they work, and two basic operations that form the foundation for more advanced techniques in fields like data science and machine learning. A vector can be thought of as an ordered list of numbers. Each number in a vector represents a feature or a measurement. For example, consider a vector representing a house. The first number in the vector could represent the number of rooms. The second number could represent the square footage, and the third number could represent the price. Mathematically, this vector can be written as x equals the vector with entries 3, 1200, 300,000, where 3 is the number of rooms, 1200 is the square footage, and 300,000 is the price. Vectors can also represent points in multidimensional spaces and are often visualized as arrows. For example, vector v can be represented by an arrow originating from the origin and pointing to the coordinates x equals 6, y equals 8, and z equals 10 in three-dimensional space. In this lesson, we will focus on two basic operations on vectors, addition and scalar multiplication. Let's begin with vector addition. Imagine a woman named Amy who has a workout schedule on 2 days of the week, Wednesday and Saturday. On Wednesday, she runs for 30 minutes and cycles for 10 minutes. This can be represented as vector 1 with entries 30 and 10. On Saturday, she runs for 40 minutes and cycles for 20 minutes. This can be represented as vector v2 with entries 40 and 20. To calculate her total effort for running, we add the running duration from Wednesday and Saturday, which is 30 plus 40 equals 70. Similarly, to calculate her total effort for cycling, we add the cycling durations from both days, which is 10 plus 20 equals 30. Now, her effort for the week can be represented as vector v with entries 70 and 30. This is an example of vector addition. We added the first entries of the vector together and we added the second entries together. This operation allows us to combine the data from multiple days into one representation. Now, let's move to scalar multiplication. Imagine Amy has a consistent workout schedule for 30 minutes of running and 10 minutes of cycling on Monday, Wednesday, and Friday. The effort for a single day is represented as the vector v with entries 30 and 10. Since she works out 3 times a week, we scale the vector by a factor of 3 to calculate her total weekly effort. For running, we multiply the running duration by 3, which is 30 times 3 equals 90. For cycling, we multiply the cycling duration by 3, which is 10 times 3 equals 30. Now, her weekly effort can be represented as vector v with entries 90 and 30. This process is called scalar multiplication. We multiplied each entry of the vector by the same number, or scalar, to scale it up. Graphically, this stretches the vector proportionally, increasing its magnitude while keeping its direction the same. Both vector addition and scalar multiplication allow us to summarize and scale data effectively. These operations form the foundation for analyzing, visualizing, and transforming data in real-world applications. Key takeaways. Vectors are ordered lists of numbers that can represent features, measurements, or points in multidimensional spaces. Vector addition combines two vectors by adding their corresponding entries. Scalar multiplication scales a vector by a single number, stretching or shrinking it proportionally while maintaining its direction. These operations are fundamental for data analysis, making it possible to represent, summarize, and manipulate data in meaningful ways.